Hello everyone, today let's solve the problem theater square. So this was asked done Codeforces beta round 1. So you can just go through the question. I'll just summarize the question so that it will be easier for us to solve the problem. We can just go through the question, man. It is easier to understand basically, right? So what the question states here, we are given a rectangle square. Just give me a second, 1 second, 1 second. So yeah, here we are given a rectangle theater of size n into m. We are given a rectangle theater of size n into m. We want to cover this entire area using the square flagstones of size a into a. We have to cover this one. We have to cover this entire area using square flagstones of size a into a. A into a. This part is very important. Again, I'll read out this one loud. Just listen to this. We are given a rectangle theater of size n into m. We want to cover this entire area using what? Using square flagstones of size a into a. We can't break the tiles and they must align with the square's sides. We can't break the tiles, right? So we cannot break the tiles and they must align with the square's sides, right? They have to align with the square's sides. So we have to calculate the minimum number of tiles that is needed to cover the whole theater. We have to calculate the minimum number of tiles. We have to calculate minimum number of tiles that is, yeah, we have to calculate the minimum number of tiles that is needed to cover the whole theater. That is needed to cover the whole theater, right? Whole theater. This is fine. We have to calculate the minimum number of tiles that is needed to cover the whole theater, even if some tiles extend beyond the borders, even if some tiles, this one, extend beyond the borders. So what we need to do, we have to calculate the minimum number of tiles that is needed to cover the whole theater. So minimum number of tiles that is needed to cover the whole theater. So that's what we need to basically this one find out, right? So again, just listen to this. We are given a rectangle theater of n into m, size n into m. We want to cover this entire area using flagstones of size a into a. Flagstones of size a into a means we are considering the flagstones which are of size a into a, right? Which are of size a into a. This is fine. We can't break the tiles. We cannot break the tiles and they must align with the square sides, right? We have to calculate the minimum number of tiles that is needed to cover the whole theater, even if some tiles extend beyond the borders, right? So that's what we need to calculate here. So this part, I hope the question part is completely clear, man. I hope the question part is completely clear. Very easy to understand, right? So let's come to the input output part here. This one, we have been given 664 here. We have been given 664. Just give me a second. What happened to this one? Yeah, this is fine. So here, this we have been given n into m here. First, this one is nothing but n. 6. This one is nothing but this 6 is nothing but m. Just give me a second here. This first 6 is nothing but m. Second 6 is nothing but m, and this part 4 is nothing but here a. So this one a into a. Each flagstone we have been given the size a into a, right? So this one is a. This is nothing but n. First one, second one is nothing but m, and a is nothing but the 4. The output that we need to get, or this one, what do we call? The minimum number of tiles that is needed to cover the whole theater would be 4 here in this case, the output, right? So I hope the input output part is completely clear. They have given only one example here in this case. Yeah, let's try to solve the problem. Let's try to solve this problem basically. So let's discuss the approach first, followed by the complexities, and then let's write the code. I hope the question part and the input output part is completely clear, man. Right. So now let's discuss the approach followed by the complexities, and then let's write the code. Initially, as usual, let's discuss the approach. So here I have considered the same example that they have given in the question, first example that they have given in the question. So we have been given n equals 6, m equals 6, and a equals 4, and the output that we need to get here is 4 as well. So we will be going with a try along with a DFS. Just remember this one. So this is very important basically. The data structure or the approach that we'll be going with is try along with the DFS, right? So you can just solve this one using any other approach as well, using other approaches as well. So try, um you'll understand the problem clearly if you make use of the try for this particular problem along with the DFS, right? So that is the reason I went with the try, to be frank. So here we have been given n and m6, a we have been given 4, and the output that we need to get here is 4. The approach that we'll be going with, or yeah, the approach that we'll be going with is mainly try along with the DFS, right? So here let's move on with the step-by-step explanation. We are going with the same input 664 here. So theater size we know, n we have been given 6, m we have been and m we have been given 6, and the flagstone size we have been given a equals 4. This one I'm speaking of input, right? Along the side, we have to go with 6 by 4, nothing but this is nothing but seal of n by a. This is this step m side. First we have to go with, along the n side we have to go with m side as well. This is nothing but seal of m by a. The first step is nothing but this is seal of n by a, this one, and this one is nothing but seal of m by a. So this is nothing but 6 by 4. 6 by 4 math dot seal of 6 by 4, this we will get 1 point something. Finally, as we are going with a seal, we will get the 2, right? Same thing, m also we have 6, so 6 by 4 here. Now it m by a, right? Seal of m by a, so math dot seal of this one, 1 point something will lead to 2 itself. So we have two tiles here. So total tiles we got here is 4. Total tiles we got here is 4. 2 plus 2 here. 2 plus 2 will lead us to the 4. So total tiles or the final output that we got here is 4, right? The output that we got here is 4, which is equivalent to the output that they have given for the example 1 in the question. So our approach works absolutely correct in this case. Our approach works absolutely correct in this case. As we are completely familiar with the approach, let's discuss the this one. What do we call? Complexities part very quickly, right? So what will be the time complexity here? The time complexity would be big of 1. So why it is big of 1, you can ask. It is why is it not big of n instead of it is big of 1? Because we will be making use of only few big integer operations, right? So which are independent of the actual values. So we will be making use of the big integer. So to make use of the big integer, we have to go with we have to import the math, this one package, right? So we have to go with java.math dot this thing something dot star. So we will be making use of the this one big integer, right? So only few big integer operations are done here, and also big integer operations will be making use of will be independent of the actual values, that we need to keep in mind. And the space complexity would be big of 1 as well. We will only store 3 big integers and one try, right? So here in this case we can solve this without try as well, but if we solve this one with the try, it will be really easy to understand the problem. So that is the only reason I have made use of try for this particular problem. You can just go with the other approach easily. So you can just solve this one with the other approach very easily. So even though you can solve this one easily with the other approach, using the try will make us understand about the try and how to implement the basic try operation. So that is the reason I have made use of the try for this particular problem, right? So we are storing 3 big integers and 1 try, right? So the overall space complexity would lead to big of 1. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of 1, right? Now as we are completely familiar with the complexities and the approach, it's better, we are good to write the code. Let's start writing the code. So let's start writing the code. I'll just come to the compiler here. So yeah, first uh, we'll be going with the fast input and output. So we need to import the input output package, and also we'll be making use of the big integer as we discussed in the approach. So we have to go with the math operation, this one math package as well. So this one also we have to also we'll be making use of different utilities. So I'll just go with the utility package as well. So I'll just go with here import java dot input output star. So we'll be making use of the big integer as well. This will be java dot math dot. So this will be big integer. This is fine. The final one is we'll be making use of the different utilities. This will be import java dot util dot star. So this is fine. Next, let me go with the main class. Let me go with the main class. This is fine. So first thing is we'll be making use of the try node to store the input string character by character, right? So we'll be making use of the try node to store the input string character by character. So we have to store the input string somewhere, right? So we to store the string character by character, we will be making use of the try node here. So I can just write it in this way. Just give me a second. So this will be static class. This will be try node. This is fine. Within this class, what shall I do? Let's map the children characters here. So let's go with a hash map, man. So I'll just go with hash map here. This one will be character, comma, try node. So this one will be children. So let me assign this one to the new hash map. So this is fine, new hash map. So the next part here would be we have to flag to mark the end of the string. We'll be making use of the flag. Basically, when I say flag, it is of the boolean value, right? So boolean value, true or false. Basically, we'll be going with a flag. So here I'll just go with boolean. Uh, I'll name the variable isn't and let me assign this one to false. This is fine. So the next part is we will be going with a full string that is stored at the end. So this one will be string stored string stored string equals. So this is fine. Yeah, let me come out of this one entirely. So let's go with the try class to insert and retrieve the input string. Let's make use of the try class to insert and retrieve the input string. So I'll just go with static here, static class. This one will be try. This is fine. So first, as usual, within the try we have to go with the root node, right? So I'll just go with the try node. So here let me make use of the variable root and assign this one to, we have to create the this one try node. This is the root node, first node always. So we have already solved n number of try problems. We have to be knowing this at this point of time, right? So now we have to insert the input string into the into the try. First we have to insert the input string into the try, means by character, right? Sorry, character by character we have to insert the input string into the try. That is the reason we are making use of the try. So basically, let me tell you one thing. We'll be going with the insertion, deletion or the retrieval, insertion, retrieval, as well as dfs retrieval. So retrieval will be making use of the dfs basically for the retrieving, for the retrieving, right? So we will be going with the insertion part where we will go character by character basically, right? So we will store the input string character by character within the try. To retrieve that one, we will be making use of another method, nothing but retrieve. So for that retrieval part, we will be making use of the dfs. I hope this part is completely clear, man, right? I don't want to say this again. So I hope this part is completely clear. First, what shall we do? This is just the class try, right? So next part is we will be going with the insertion first, insert method. So I'll just go with void insert. So I'll just consider the parameter word here. I'll just consider the parameter word here. So this is try node. Again, let me assign this one to root. This is fine. Let me make use of the simple for loop because as I've said, we will be going with each character. So I'll just consider each character ch of word dot to char array. So this is fine. So me let's carry on with a further step. So here we have to create the child node if it does not exist. So we have to create the child node if it does not exist. So I'll just go with node dot children, node dot children dot put here if absent, if absent. So here I'll just go with the ch comma new try, new try node. This is fine, new try node. So we are just creating the child node if it does not exist at all, right? So then we have to move to the next node. If it exists, then we have to move to the next node, right? So then I can just assign node to where is this node dot children, children. So we have to get the value from the value of the individual character, next node, right? So we have to get the value of the next character, means get of ch. So I can just make use of the get operation here, right? So we have successfully moved to the next node. So next what we need to do, I'll just come out of this one. Next we have to mark the end of the string. As we are going with the try, we have to mark the end of the string and we have to store the original string. So these two things we are left with basically. So first let's mark the end of the string, nothing but here node dot is end. Let me assign this one to boolean value true, and also node dot I'll just go with stored string here, and let me assign this one to the word 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 itself. Means here we are storing the original string, right? So let me come out of this one entirely. First what shall we do? We have to retrieve stored string by the dfs. We have to retrieve the stored string by dfs. Means I'll just go with the string here. I'll just go with retrieve here. This is fine, retrieve method. So here to retrieve the string, we will be making use of the DFS. We have to retrieve the store string by DFS. So we will be making use of the DFS in simple terms, right? So let me first write the helper method DFS retrieve and then make use of that one in the main method, nothing but retrieve in this case. So this is nothing but the DFS to find the stored string. So this will be, I can write in this way, private string. I'll just name the method DFS. So retrieve, this is fine. So let me scroll this one. Yeah, dfs retrieve. So this consists of the parameter, this one node. So it has to consist of the node. This is fine. So first thing is, let me go with if node dot isn't. So yeah, this is it. Then we have to return the stored string. That itself is the stored string, right? So I can just write here node dot stored string. So this is fine. Let's go with the iteration part next. So we are just performing the pure DFS man here. So this one will be try node. So let's consider the individual child of the all the children values. From all the children values, let's consider the individual child. So this one will be node dot children dot this one values. So I'll just go with the values here. This is fine. Let me open the this one, what do we call flower bracket here. So this one, let me go with the result here. Let me go with the result variable here. We have to store this one somewhere, right? So we'll be making use of the result variable here. So let me go with the recursive part here, nothing but dfs retrieve of child. What we need to retrieve? The child node, nothing but child here in this case. So if result is not empty, then only we have to return result. If result is empty, we don't have to return anything in that case. We just have to return the empty string, right? In that case. So if result is not empty, result is not empty means not of result dot is empty, then we have to return result, right? So this is fine. Else we have to return this one empty string. So we are done with the dfs retrieve method. So let's make use of this method inside retrieve method, right? Main method. So here I'll just come here, let me give return dfs retrieve, and we have to perform the dfs starting from the root. So I'll just give root here, right? So this is fine. We are done with the try part. We are done with the try and the dfs part. Let's move on with the main function here. Let's move on with the main function, right? So I'll just give main. Initially main function consists of the input output part, right? So before, so why, just give me a second here. Let me remove this one, and also let me make use of here throws input output exception. This is fine. So within this method, within the main function or the main method, so what we will be doing, we have to read the input and from the standard input, and also we have to go with the, so in short terms we will be going with the I mean in simple terms we'll be going with the fast input and fast output. For the fast input I'll be going with a buffered reader. So this one br equals, so new buffered reader, new input stream reader. So this is fine. This will be system dot in. This is also fine. Next, let's go with the uh, print writer. Print writer. So this will be output. This is equals new print writer. This one will be new. Uh, new output stream writer. We can call this one new output stream. New output stream writer. So basically, before the output stream writer, I think so we have to go with the buffered writer here, right? So within the buffered writer, we have to give new output this one. What do we call output stream writer? So this is fine. This one will be system dot out. So this is it for the input and the output, fast input and the output part, right? So next we'll be making use of the input line. So we have to go with the format n, m, and a. In the input we have been given n, m, and a, 6, 6, and 4, right? If you remember. So this one I'm speaking of, man. This is nothing but first one is n, second one is the second value 6 is m. This is nothing but a. We have to go with the format n and m, n, m, and a. So I'll just go with the string. This, let me call this one input line, and let me go with the buffered data dot read line. So this is fine. So the next line here would be we have to create the try instance. We have already written the try here, this one. Custom try we are making use of here, right? So this one. We will be making use of the try instance over here. So I'll just go with try, try equals new try. This is fine. So we are just going with the, or we are just creating the new try instance here. And next we have to insert the input lines into the try. We have to insert the input line into try. That is the reason we have made use of the try basically, right? So I'll just go with try dot insert, try dot insert of this one input line. So this will be input line. So this is fine. We are just inserting the input line into the try. So this is fine. So the next step is we have to retrieve and split the input into n, m, and a. So for retrieval, we have already written the retrieval method, retrieve method, right? So where we have performed DFS helper method, where we have took the help of the helper method, this one DFS retrieve, and we have successfully returned the retrieve method, right? So we have to retrieve and split into n, m, and a. So how can I articulate that one in the form of code? This will be string, and this will be input equals, this one will be try dot retrieve. So retrieve, I'll just give here retrieve, um, and we have to split as well, right? Because we have space, between the numbers. So this is fine. So we are just retrieving and splitting the input into n, m, and a. So between the inputs we have space 6, 6, and 4, right? So that is the reason we are making use of split. So the first thing here would be we have to go with the length of the square, width of the square, as well as size of the each tile. Size of the each tile. First, let's go with the length of the square. So here we'll be making use of the big integer, right? Big integer. This one will be n equals new. This one will be big integer of input. This one will be 0. Fine. Let me copy the same thing over here. Let me copy the same thing here. Let me paste it in the next line here as well. So this one would be an m, and this one would be a. So this is fine. This one would be, instead of input of 0, this would be 1. So let me delete 0 here. This one would be 2. So this is fine. Let me come out of this one entirely. So now we have to compute the this one. Compute accordingly with the this one. What do we call? N by A, M by A we did, right? So for the computation, seal of N by A, seal of M by A, if you remember the approach. So that's what. So we have to compute the compute seal of n by a and seal of m by a along with this one. N by a, m by a is nothing but we can write in this form as well. N plus a minus 1 by a. If we are going with the integer, if we are going with the integers, we can just write it in this way as well. N plus a minus 1 by a as well. So how can we articulate the same thing in the form of code? So here I'll just give big integer tails along n. May assign this one to n dot add of a. So this one will be dot subtract. So this one will be big integer dot 1. So this one will be divide. So this one will be divide of a. This is fine. And the same thing. Let's go for the m now. Instead of n, I'll just make this one m. This remains same one. N dot add of a dot subtract big integer dot 1 of divide by a. So we are in simple terms we are going with ceil of n by a and ceil of m by a. These two lines accordingly with the approach. We are just articulating the same thing that we discussed in the approach in the form of code now. That's it, right? That's what we are doing here. So the next step after computing this one accordingly with the formula ceil of n by a and ceil of m by a, we will be going with the total tails, nothing but tails along n into tails along m. So I can just go with out dot print ln here. So this would be tails along n, tails along n. So I'll just go with tails along n. So this will be multiply this one tails along m. So where is tails along m? This one. This is fine. Yeah, the final thing is we have to flush the output here. In this case it would be out dot flush, or you can just make use of out dot close as well. It doesn't matter, right? So here in this case we are done with the coding part. So this is it for the coding part. We have successfully made use of the try as well as the DFS, right? So we are going with the try with the DFS to solve this particular problem. Along with that we are making use of the big integer here. This is fine. So now before uh, checking whether the code works perfectly or correctly or not with certain inputs, I just want to copy paste the signature starter template. Just give me a second here. So let me come here. So yeah, let me paste it over here. So you don't have to worry about that starter template. So let me do one thing. Let me come here. So let me copy this one and we have to get the output 4. So let's try with the different inputs here, man. So we have oh, so I haven't closed the parenthesis here, this part of the parenthesis. Line number 68, where is it? Let me close here. So yeah, this is fine. Let me run this one again. Again we have two more errors. Main 68 uh, square bracket, it is expecting square. Oh yeah, I haven't. Okay, this is fine. Now this error has to go. Oh, how many errors we have here? 8 errors. Okay, let's clear one by one. Cannot find the symbol try node. Where is it? Line number 35. Just give me a second here. Try node root. So we have made use of the try node, right? So try node within the insert we are making use of here. So this one try node. Oh yeah, this one has to be node actually. This one has to be class try. So this one has to be node, not the root actually. So this is fine. Then we are assigning the try node to root. So this is gone, I think. No, we still have the same thing. So just give me a second here. This is try. This has to remain root itself. We have to start with the root. I got confused with this one, man. So here we have try node. Mm, here we have to have the variable node. So I forgot the variable completely. I didn't write the variable itself. Node variable. So yeah, now most of the errors are gone. Still we have the error. Error cannot find the symbol buffered. So I have misspelled buffered here. You can clearly see line number 60. Where is 60? So yeah, buffered right. So now if I run this, yeah, we have one error left, that is new try. This T has to be capital. Where is line number 63? Yeah. So here let me run this one. Yeah, now we have the output 4. means the code works absolutely correct, right? For the input, we have to get the output 4 itself. We are getting the correct output. So let me do one thing. Let me copy this entire thing. Let me come to the submitting part here. So we have already selected A. So let me paste this one. This is A, problem A itself, right? 1A. This is fine. Why this is not allowing me to paste? Just give me a second here. Let me choose the problem A. Yeah. Now let me paste it. Let me hit the submit button. I hope this works for all the test cases, man. Let's see. Can see here running on test one. Let's wait for some time. Wrong answer on test 3. Why? Let's check what answer we are getting here. So 211, we have to get the output 4. Instead, we are getting the output 2. I mean, we have to get the answer 2, but we are getting the output 4. Sorry. Uh, let's check what we have done wrong, right? So what mistake I have done here is here in the line number 72 man. So here I have copy pasted this one I think. I mean I copied this one I think. I pasted the same thing. I changed this one from N to M. I forgot to change here as well. So here we have to go with M, right? So we have to go with M dot add of A, right, instead of N. So this mistake, that is the reason we were getting the wrong output I think. So let me run this one again. This works fine. So here in this case, just give me a second. Now let me copy the same thing. Let me remove this one and let me paste it over here again and let me hit the submit button. Now this has to work for all the test cases correctly. Let's see whether this works or not. Let's wait for some time. So here you can clearly see the sample, I mean, all the test cases are getting passed, means the code got accepted, right? So here, whatever the code that we have written works perfectly for all the test cases. Whatever the code that we have written works well for, fine for all the test cases, right? I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.